No, yeah, it's a element noise.
We realize that with vectors, using vector analysis, the resultant, which is the third force, will be along the diagonal. Okay. So we can draw an equal vector of the 4 Newton and sorry, this is 3. This is 4, this is 3. An equal vector of the 3 Newton and put on the head of the 4 Newton by drawing using equal vector approach. As I said, vectors are equal when they have the same magnitude, direction, and are parallel in space. So if this is 3 Newton, because this is the equal counterpart of this is also 3 Newton because they have the same magnitude, direction, and are parallel. Okay, so what we have here, we have a right angle triangle. We have a right angle triangle, and this would have to obey Pythagoras theorem, meaning that when we square the unknown, which is certainly the third force. Akosia?
Yes, sir.
Your hand is up.
Mr. Yeah.
Yeah. Quick one. Okay, let's finish. I'll give you time for questioning. Okay. I'll give you time for questioning. So we could deduce that from Pythagoras theorem, the square of this unknown, which we are representing by the letter C squared is equal to the sum of the squares of the other two sides. So when we square 3 and then add it to the square of 4, it should be equal to C, which is the resultant. And this is the Pythagoras theorem. All right. 3 squared is 9, 4 squared is 16. So C squared is 25. Therefore, C is equal to the square root of 25, which is 5 Newton. And this becomes the third force, okay, the third force or the resultant force. And I explained what resultant force is. What is a resultant force? A resultant force is that singular force whose effect is equal to the combined effect of a number of forces. Are we fine?
Yes, please.
Yes,
Then,
please.
the second question demands that
Please.
the second question demands that we find the angle between the 3 Newton force and the third force, which is our resultant force. Now C is equal to 5 Newton. Okay. Earlier, we placed 3 Newton force here. The 3 Newton force was here, and then the forward. In fact, once the question doesn't state where it should be, you can put it at, okay, being as the opposite or the adjacent. The choice is yours. So if you're assuming our 3 is here, then this is the angle between the third force and the 3 Newton force. Okay, if the 3, we change the position and 3 is here, 4 is here, and then this becomes the angle between the third force and then the 4 Newton, the 3 Newton force. So it depends on where you put either any the 4 Newton or the 3 Newton force. Please, are we fine?
Yes, please.
Yes, please.
Okay, so in determining the angle, we use the trigonometric ratios. And what did I say about the trig ratios? The trig ratios are simply the ratio of the size of the right angle triangle. The ratio of the size of the right angle triangle. You can take And there are three ratios: the tangent of the angle, the cosine of the angle, and the sine of the angle. I'm using basic because we have other ratios which you get to learn in EMATS, but these are the basics. When we talk about the tangent of the angle, our angle in question is tangent. So tan of the angle. Tan, we are talking about ratio of the opposite side to the hypotenuse. Sorry, to the adjacent. And so this is shortened as TOA, which will enhance easy recall of this TOA. So at the mention of TOA, it means you are talking about the trig ratio tangent, and it is opposite over adjacent. So when we apply this here, tangent of the angle in question theta is equal to the opposite, which is 4, over the adjacent, which is 3. 4 on 3 is 1.3. Right?
Yes, please.
Good. So theta therefore will be equal to the tan inverse of this decimal value. So on your calculator, you press shift tan and then input this decimal value. And the calculator, when you enter, will generate it for you. And we got theta to be equal to, is that 53? Approximately 53 degrees. Is that right?
53.1. Yeah.
Okay, so approximately 53. All right. Then we can also use cosine. So depending on the information you have now, we have all the three sides. So we are free to use any of them to find the angle. If you want to use cosine, cos of the angle theta is equal to, cos is the ratio of the adjacent side of the right angle triangle divided by the hypotenuse. So what's the adjacent? I'll work on the board. Give me some time, okay? What's the adjacent? The adjacent is 3. What's the
3 Newton.
So 5. You see here, the units will cancel out. Okay. So we have 3 on 5, and 3 divided by 5 is 0.6. So theta therefore becomes the cos inverse of 0.6. And you have the same answer as we got for tangent. Okay. If you want to use the sine of the angle, sine of the angle theta is equal to opposite, which is 4 on hypotenuse, which is 5. And so 4 on 5 will be equal to 0.8, correct? Correct?
Yes, please.
Yes, please.
Yes, please.
Mute yourself for me. The feedback is quite disturbing. Therefore, theta is equal to the sine inverse of 0.8, and that would also give you the same answer as we've had before. Any question? If you have any question, quickly bring it up so we could move on. I could see 3 hands raised. Go ahead. First one, go ahead with your question. Hello, I'm listening. Those of you who want to ask a question, go ahead.
Mr. Dia, please, the B says the angle between the 3 and during Newton force and the third force.
Yeah.
So the 53.1, are you supposed to leave it in degrees or you just write 53.1?
Oh, it's an angle, so degree.
Okay.
Okay. All right.
Yes, please.
The second, Akosia.
And please, with the trigonometric ratios, are you supposed to use only one for your answer, or
You see,
the three?
we tested all the three because we have all the sides. So if you have all the sides, okay, you can use at every point in time, you can use only one, but it depends on the information available to you. Okay, it depends on the size of the right angle triangle given to you in the question. Okay.
Yes, please. Yes, please. Thank you.
All right. So now, if the angle is not theta, but it's maybe alpha, how do we go about it? And I'm taking you through this because you are beginners, okay? You haven't done much, so you may not know, some of you, I mean. So if the angle is not about theta, example, determine the angle between the 4 Newton and then the third force. Okay, how do you go about it? In this particular situation, there's the angle. Now, yesterday I told you that the angle given determines which side is the opposite, which side is the adjacent. The hypotenuse is always the longer side of the right angle triangle. So if this is the angle in question, then the side which is directly opposite to the angle is this side, isn't it?
Yes, please.
Yes.
The opposite and then the adjacent always, okay, have a special relationship, and that is they are perpendicularly to each other. So if this is the opposite, this side automatically becomes the adjacent, and the longer side is always the hypotenuse. Therefore, this angle, if I want to use tangent, tan of the angle alpha becomes the opposite, which is 3, divided by the adjacent, which is 4. Now look at something. Even when we earlier determined this angle 53, approximately 53. Once this is 53 and this is 90, what will be this side? If there's 53, this is 90, what will be this side? Yes, quick one. What will be this angle?
36.
So,
37 degrees.
yes, so
37.
if this is 90, if this is 90, it means this plus this must also sum up to be 90. So this angle becomes 90 minus theta, which is 53. So alpha becomes 90 minus 53. And so that is 27, right?
37.
37 degrees. Let's use this and see. We are saying that tangent is opposite this side over this side. Divide 3 by 4. 0.7 5, right? 0.75. Therefore, the tan inverse of 0.75. Take the tan inverse of 0.75. What's the answer?
36.89.
36.8.
So, approximately 37. Is that okay?
Yes.
That's the power of trig ratios. That's the power of trig ratios. So, yes, trig ratios, Pythagoras theorem are mathematical concepts, but we physics, as I told you last time, the language of physics is mathematics. So we apply it so much or a lot in our various concepts. Okay, yes, let me pick the views of Gloria. Yes, for Gloria, go ahead.
Mr. Ada, please.
Where I'm listening. Oh, okay. Then let's have Adjoa. Adjoa, come in. Adjoa. Oh, are you there?
The first solution that you did, the one you took, but this one right now, taking 3 as.
Oh, I'm not getting a good feedback from you. Adjoa, you can send.
Mr. Please, I said that with the first solution that you did,
Yeah.
you first took the opposite as 3 Newton for the tangent, but now you are taking 4 Newton as the opposite. So the first one that we did, we got 53.1 degree, but now we are getting 37 degrees.
Yeah.
Please, I wanted the explanation.
What I'm saying is that if the question is not clear on which one is actually the opposite and which one is the adjacent, it can change. Is that okay? It can change. Usually the size of the right angle triangle A, B, C. Actually, the C is always the hypotenuse. The A is the opposite and B is the adjacent. So if I draw a right angle triangle, this side C is the hypotenuse. This side A, okay, is the opposite. And then this side is the adjacent. So when the value is given in this order, 3, 4, 5, then it means this is the opposite, this is the adjacent, and this is the hypotenuse. Is that okay?
Yes, please.
All right. Did you also do something in simultaneous equation in mathematics?
Mr. Idua.
Hello.
Please, can you read the question for me?
I'll send it. I'll send it to the platform so you can pick it from there. Okay.
Please, everything is just one word I can't see. 4 and 3 and respectively are. Please, what are
acting perpendicularly.
Are what?
Acting perpendicularly. 90 degrees. They are acting perpendicularly, meaning they are of the angle between the two forces is 90. Are you okay?
Yes, please. Thank you.
Good. Did you do simultaneous equation? Solving of simultaneous equation?
No, please.
No, please.
You did it?
Yes, please.
No, please.
Okay. Okay.
No, please.
Yes.
No, please.
Let's go through a simple simultaneous equation and how we can also apply in physics to solving problems. Okay. So I'm giving you two simple two equations in 2 variables, and then we try to solve it simultaneously. Then we apply it in solving physics problem. So if you have x plus maybe 2y is equal to 4, this is equation 1. Okay, and then maybe 3y plus or minus 2x is equal to 10 as equation 2. Okay, so these are 2 equations in two variables. And our task is to solve this equation simultaneously at the same time. Our task is to solve this equation simultaneously at the same time. How do we go about solving such a problem? Okay, I think those of you who were taken through, you were taught the method of substitution and then the method of elimination. What do we mean?
Yes.
Yes. What do we mean by the method of substitution? So let's first look at the method of substitution. I'm to solve x plus 2y is equal to 4. And then 3y, which I can rearrange as minus 2x plus 3y is equal to 10. I'm just bringing the x variable first before the y. Are we fine? In equation one,
Yes, please.
in equation 1, what I want to do is that I make one of the variables the subject and substitute it into the other variable. So I make x the subject and s being made as the subject will be equal to, yes, let me pick your views. X being made as a subject from equation 1, what would that be?
4 minus 2y.
Good. So this is
Minus 2y.
4 minus 2y. We substitute this in equation 2. So wherever we see x in equation 2, we are going to put there 4 minus 2y. Mami Adwa, ask your question. Okay, let's continue. Maybe later she'll come in with her question. So wherever we see x in equation 2, we are going to put this there. So we have minus 2, there's x here. So we substitute 4 minus 2y, then plus 3y is equal to 10. Hello, are we okay here?
Yes.
Oh, then let's expand this. Let's expand the bracket. Help me to do that. Yes, negative 2 times
Minus 8.
that's
Minus 8.
minus
Negative 8.
uh-huh,
Plus 4y.
Plus 4y.
4y
Plus 3y.
plus 3y
It's equal to
is
10.
equal to 10. 10, we group like terms, isn't it? So we add 4y to 3y, giving us 7y. Okay, 7y minus 8. We can straight away send the negative 8 to the other side of the equation. And in doing so, we add plus 8 to both sides of the equation. This side will run to 0, whereas the other side will be 10 plus 8. Are we fine?
Yes,
Yes, please.
yes, please.
So we have y, 7y is equal to 18. How do we determine y? How do we determine y?
By
Dividing by
2 by 7.
Or we divide 2 by 7 or we divide 2 by 7 or we multiply 2 by 1 on 7. So if I multiply 2 by 1 on 7, 1 on 7 is the same as dividing 2 by 7, right?
Yes, please.
Oh, so y is equal to 18 on 7. Okay, so we found y. Once we have y, we can use the same equation to find x. Because x is equal to 4 minus 2y, and y is 18 on 7. So 4 minus 36 on 7, which will be equal to, yes, 28 minus 36 all on 7. Okay, and the final answer becomes minus 8 on 7 for x. Please, are we okay with the solution? So this is solving these two equations simultaneously using the method of substitution. We are substituting one equation into the other. All right. Already,
sir,
ask your question.
sir,
Yeah.
please, I can't see the latter part of the solution on the right hand side.
The right hand side, the brightness there is so much.
Still isn't clear.
Yes. Okay, let me bring it here. Let me bring it to the
Thank you
left.
very much.
Okay.
Class.
So we have some. Please mute yourself. I'm getting a very bad feedback here. Hello.
Sister Bina. Hey, yes, no, I tried one man.
I'm coming.
Hey.
This part. Okay, let me bring it here.
Yes, please.
Let me bring it here. So we have x, we have y, so we can easily find y. So x is equal to 4 minus 2 times y, which is 18 on 7. This is 36, correct? So when you find LCM and all that, this will be 28 minus 36. And 28 minus 36 is minus 8 on 7, as we got earlier. So this is the elimination method. Gloria, your hand is up.
Mr. Yeah, please, I don't understand how, Mr. Yeah, please, I don't understand how you got equation 3.
That's what equation 3.
Yes, please.
That is how we got equation 3. I said multiply equation 1 by 2. So equation 1 times 2. Are you okay?
Yes, please.
Now this is equation 2. I multiply 2 by 2. So I have 2x plus 4y is equal to 8. And I did that with the intention of eliminating what? Eliminating what? Hello, I'm listening.
Equation 2.
Two. I multiply 2 by 2 with the intention of eliminating
The x.
exactly.
X.
Okay. So that's the elimination method. Let's see how we apply this mathematical concept. I have another person who wants to ask a question. Okay. Hey, Akusha, I've answered you. Victoria.
No, please, another question. Please.
All right. Okay, I'm dictating this question for the house.
Mr. Yeah, please, there's another question.
Yes.
So
Right.
please, with the elimination method,
Mhm.
are you saying you have to multiply with a number so that you can get rid of a variable, one
If,
of the variables?
if all the variables do not have the same coefficient, I have to multiply. Okay, here I did so because I saw that the x in the second equation is negative. Oh, and if the other part is positive, then if I multiply this by 2 and add, I can eliminate x. That's the intention
so-
behind.
So if the coefficients are the same, there's no need to multiply.
Yes, you can subtract one of the equation from the other one and you eliminate one of them.
Yes, please. Thank you.
All right. Can I go ahead and read?
No, please.
Yes, please.
Please, I have a question.
Pardon?
Please, I have a question.
Go ahead.
The elimination method, say please, the equation 2, why